Perfect. And you're muted right now, sorry.
That's okay.
There we go.
Are we okay?
I think we are.
You can hear us, Barbara?
We can hear, yeah, we can hear you now. I was
Okay,
muted.
great, wonderful. Well, thank you so much to the Native Village of Georgetown for coordinating these webinars. We've learned a lot. We've been so fortunate and thankful for the process and for your making this opportunity possible for lots of conversations. This is the fourth in the series, and we believe that there's one more. But I just wanted to briefly introduce myself, Christina Woolston, External Affairs Manager, originally from the community of Naknek. We have Vernon Chevaleria, who's originally from the Bethel area. Chris Eckert, I'm sorry, I keep forgetting your last name. Chris with our environmental team. I'm just going around the table here. Rebecca Wilmarth from Red Devil Community Relations Team. Stephen Alexi, Community Relations Team. Samantha and Gayak Miller, Communications and External Affairs. And then Enrique Fernandez, who's the head of our environmental department. And so we are thrilled to be a part of this conversation. We did want to acknowledge and recognize the landowners, Chilista Corporation and the Kuskokwim Corporation, who are the reason that we're here today. When the Alaska Native Claims Settlement Act was passed in 1971, their land selection was focused in part on the lands around Donlin Gold because they knew the minerals potential there. And the obligation to provide for opportunities in a safe and responsible way for their shareholders. And so we're thankful for their leadership and their partnership all along the way as we've developed this project over the last 25 years. I'm going to be advancing the slides.
You want to turn the camera off?
Okay, we've introduced ourselves, and to help with bandwidth issues, we are going to turn off the camera. When it comes back to Q&A, we will turn that back on, but right now we're going to start the slide presentation. And so to save that, we're going to turn off our cameras. So thank you so much. Okay, we can advance. So as I mentioned, this is the fourth in the series, and we believe there's one more with Chilista and TKC, but we have been listening, and we thank you for the opportunity to hear your concerns and your questions and to provide a lot of information that address those. These are the things that we know are the big questions that people have, and we've got a lot of information. The data and science is continuing to be improved and to be updated, and so we're excited to share some of that new information with everyone today. We did want to, you can go to the next one. So again, the landowners, Chilista and TKC, we've had a relationship for many years now. At their invitation, we are the developers of the project. Chilista Corporation and TKC have their own agreements specifically with Donlin Gold. And then they also have the rights for many opportunities within the project as a resource owner and the surface land owner, which includes many preferences for shareholders, spouses, and descendants, opportunities for subsidiary companies within their corporations, and then many opportunities down the road as operations, and also a significant responsibility, which they take so seriously. We heard that last week with Chilista talking about their obligation to manage and monitor all aspects of the project now, in the past, and in the future. And it's something that they take very, very seriously because this is their land. Next slide. So we've been working on the project for 25 years, and we have put a significant amount of time and effort into community relations, into exploration and studies, engineering, environmental, and then an 8-year process for permitting, and it's still in process right now. We still have state permits that are outstanding that we're working through. So we like to say it's a little bit like Bridgerton, if anybody watches that. We're a slow burn. This is not a rushed project in any means, and we are continuing to move forward and progress the project. But if you look at the timeline, that's where we are right now. Our goals as a team and as a company, when we invest in the community and when we engage with communities and stakeholders, is to educate, and that's two ways. We listen and we share information and the science and the data. We don't conject, we don't guess. You know, these are things that we're looking at from a scientific and a data standpoint. We want to engage with the communities and all stakeholders. We have an open door policy. Any tribe, any community, we welcome the opportunity to give presentations, to listen. As part of the EIS process, we changed part of the project design because of the input from stakeholders, and we're thankful for that engagement. We partner with our communities. We invest and come alongside where there's a need. Education, health and safety. Rebecca will talk about that in a little bit, about our partnerships. The environment is paramount to us. We are from Alaska. The entire community relations and external affairs team are from rural communities and from the region. So we just appreciate the opportunity to safely develop this project. And then transparency, next one. So we have, as I mentioned, the engagement and the transparency is important to us. And we welcome the opportunity over the EIS process and now and going forward. And this is a great example of a way to engage in an open conversation. These are examples of meetings that we've held over the years and the ways that we've engaged with communities and stakeholders. And so we're, again, door is always open. And if we can't answer your questions today because of time or other reasons, we welcome you to reach out to us and we will be sure to respond. That's right. I'm going to hand this over to Rebecca Wilmarth now, who is the head of our community relations team.
Good afternoon, everybody. Nice to see a bunch of familiar faces. My name is Rebecca Wilmarth. As Christina mentioned, I'm the supervisor of the community relations team based out of Red Devil. I'm also a Georgetown tribal member, so thank you to Native Village of Georgetown for putting this on. As you can see on this slide, these are our various forms of community investments. One of the primary functions of the community relations department that consists of Vernon, Colleen, who's not here today, Stephen, and myself, is to identify ways that we can help foster the development of safe, healthy, and thriving communities. You can see the expanse of our support in the various types of projects that fall under one of our 5 pillars of community development: education, cultural preservation, economic development, health and safety, and environmental stewardship. We work very closely with many of these communities, tribal council staff, IGAP staff, who carry out these projects year after year. And this is, not an exhaustive list by any means. We're always looking for new partnership ideas. Local hire is something that's very important to us. We take pride in it, and it's something that will continue throughout the mine life. This map is where our employees over the last couple of years call home. We really love to see employees that have participated in some of the vocational and training pathways that we support, such as Excel and Avtech. As always, we're excited about all of the jobs the project will bring to the region. I won't go through these, but you can see it's quite a long list, and wanted to put a plug. We're currently recruiting for a number of positions to kick off our 2022 drill program this month. So if anyone is interested, please don't hesitate to put an application. Thank you. I'm going to turn it over to Enrique now, who's going to kick off the technical discussion.
All right, thank you, Rebecca. Let me just get close to the microphone. Can everybody hear me well?
Yes.
Excellent, excellent. All right, so, first I just wanted to, to mention, so we started the presentation by saying, that we've, through this series, we've heard, comments from people, and that's how we've designed this presentation. We're going to be talking about tailings dam, and we're going to be talking about the temperature in the water in Crooked Creek, and we're going to be talking about mercury. We're going to be talking about fish. Okay, so those are the topics that we're going to be covering today. So to start, the first one is going to be discussion on tailings, okay? And something that we hear often from the community is concerns about the Donlin Gold tailings dam, and every time there is a catastrophic failure from a dam, somewhere in the world, everybody gets concerned about our tailings dam. And what I'm here to show you today is that the tailings dam construction for Donlin is fundamentally different from all these other facilities that have failed, in recent times. I'm talking specifically about Mount Holly and the Fondo mine and Kedian and Feijao, and the type of failures that occurred on those mines and those dams would not be, our design is not susceptible to the same type of failures. So I'm going to explain that to you through my slides. Okay. So let's start, take it back one step, okay, and then let's talk about what are tailings and tailings storage facilities and tailings dams. So tailings are the materials that will be left over after the gold is separated from the rock. It looks like a slurry of pulverized rock and water, kind of with the consistency of toothpaste. Okay, here are some pictures of samples of tailings that were done years ago for a Donlin Gold project. The first picture you can see, it's a very liquid slurry, and the other picture you can see is the water has been drained and it's kind of more like a toothpaste type material. Okay, so that's what the Donlin Gold tailings would look like. The tailings are stored in what is called a tailings storage facility, or for short, TSF. Right now, you're looking here at the layout of the Donlin Gold project, and if I can move my mouse over here, you can see the open pit, and you're looking at it like at the largest development extent for the project. Okay, so there's the open pit, there's the waste rock. The mill would be here, and here's where the location that we have selected for the tailings storage facility, which is in the Anaconda Creek Valley. That's for reference. Here is Crooked Creek. Here is American Creek coming into Crooked Creek, and here is Anaconda Creek, and Crooked Creek flows, into the Cosquequin River. Okay. So a tailings storage facility includes two main components. One is a tailings dam, and the other component is the impoundment. Impoundment is where the tailings are placed, and the tailings dam is what holds the tailings in place. So let's look now at how our tailings dams generally built. We start from the ground up. Okay, so we pick the location. Normally, you try to pick a valley if possible, and then you build a foundation, and then you build a tailings dam. Okay, the first, tailings dam are not built all at once. They are built in phases, and the first phase is usually called the starter dam. Once you have the dam in place, then you start depositing your tailings, and over time, the tailings dam fills up. And it's important to note, so when the tailings get deposited, the water settles, okay? And they separate, the solids settle, and they separate, and you form a little pond, and you have a beach with the drier sediments, okay? And as you go over time, you fill your starter dam, and then you have to increase the height of your dam, and those are called lifts. So normally tailings dams, they have multiple leaves. For Donlin, we're actually looking at a total of 7 dam leaves, which will bring the tailings dam to a total height of 471 feet. Something else that we have in our design, just since we're talking about our dam, is we're going to have a 60 mil liner to contain also the deposited tailings. Okay. So here are some pictures of tailings dams in Alaska, because there are several tailings dams already in Alaska. They're all burning. This one, for example, is a picture of the Red Dog mine taken in 2019, and they were working on a tailings dam lift. This one here is a picture that I took in 2017 from the tailings dam at Fort Knox. They were also increasing the dam height. And then on the right, it's a picture that I thought it does a good job at showing how the tailings are the tailings are discharged into the tailings storage facility. It's usually just like this. There is a hose. Sometimes there is a more evolved discharge point, but there is a hose, and then the tailings get discharged, and the solids settle pretty quickly, and the water starts to separate, forming like a pond. And you can kind of see on this picture, there is like a beach here, and you can see a more wetted area here. That I'm sure if I would be able to look farther to the right, I'm sure there will be a water pond here. Okay, but that gives you an idea of what this looks like. Now let's look at how the different types of tailings dams are constructed. Okay, there are 3 main construction methods for tailings dam. One is called the upstream construction. Then there is also one called the downstream construction. And wait, there is one called the centerline construction. All right. The one that Donlin is going to be using is the downstream construction method. So I want everybody to remember that downstream construction method. Okay. Now we're going to talk how each one of these differs. Okay. So let's start with the upstream construction method. The upstream construction method involves a starter dam that is constructed on the downstream side of the facility. Then each raise shifts the center line on the top of the dam in the upstream direction. Now the downstream construction, which again is the one that Donlin is going to be using. The downstream construction method is named this way because every raise of the dam is supported on top of the downstream slope of the previous section. So every time, as you build the dam, the center line of the dam, it keeps shifting on the downstream direction. Again, this is the Donlin dam. And then there is the center line construction, which it's a combination really of both methods, okay? And every lift is on top of the other. It kind of expands on the downstream direction too, but the center line of the dam, it remains on the center. Now, just bear with me 1 second here. Before we go into the next discussion, we're gonna talk about liquefaction. And I'm sure that many people have experienced, like when you go in the Kuskokwim River and you put your feet in the water and you're sitting there on the mud, sometimes you can feel maybe your feet sinking in the mud a little bit, okay? Or if you're close to the water and there's some sediments there and you tap it with your hand or with your foot, if you tap it really quickly, it kind of turns into jello, okay? That's called liquefaction. And I have a little video that is going to explain it here, but it does a better job than I do. But just bear with me for a few seconds.
For the second experiment, we use the same container with saturated sand, but it's saturated up to a certain height. On top is a layer of drier sand, which provides stability for the rocks on top of it. Buried in the sand is a ping pong ball. When we shake the container, the stones appear to sink, while the ping pong ball appears to float. This phenomenon is called soil liquefaction. It's a phenomenon that occurs in the real world with dangerous consequences. During earthquakes, even buildings can sink into the ground as a result of soil liquefaction, in which saturated soil loses strength in response to an applied stress. Soil liquefaction is caused by Reynolds dilatancy.
Okay, so this is soil liquefaction. Okay, and it's gonna come handy for the next slides. So let's now talk about how these methods compare. Okay, now we know what they are called, you know, upstream, downstream, and centerline, but what makes them different? Okay, well, for the upstream and the downstream centerline construction, the tailings are played so they form a beach that becomes the foundation for every dam raise. Okay, just look here, for example, here's the tailings deposited. As you can see that every time there is a raise, that raise sits on top of those tailings. The same thing for the center line. Okay, that's not so for the downstream design. So in the upstream and the center line, the stability of the dam, this is very important. The stability of the dam is dependent on the strength of the tailings. Now, what happens because the waterlogged tailings, just like we show in the video, when they are under load or maybe from an earthquake, can be liquefied. It is very, very important that the water is kept away from the dam. Okay, it's very important that when these dams, the upstream and the center line, it's very important that the water pond is kept away from the dam. Okay, if the tailings liquefy, then it affects the structure of the impoundment itself. And again, this is for the center line and the upstream construction. For the downstream construction, the downstream construction are the most robust type of tailings dams and are well suited for conditions where large volumes of water may be stored along with the tailings. As compared to the upstream and the centerline method, the stability of the downstream dam is not depending upon the strength of the tailings. This is the tailings design that Donlin has and proposed for the project. This is our design, the downstream. The downstream dams are the most resilient dams in areas with potential seismic activity. Okay, when you can basically, these dams, you can shake them like a bathtub and they are okay. All right, these dams is different. You know, they would lose the, you know, center line and the upstream, they would lose the integrity. So let's look now that we understand these concepts of the difference in design and the hazards of liquefaction and how it affects each different construction method. Let's, sorry. Let's look at the recent dam failures, okay? And let's start with, you know, Mount Poly, okay? Mount Poly, the tailings dam on Mount Poly failed in 2014. It was a modified centerline dam with an upstream raise, okay? Some dams, they include multiple designs methods. Again, this Mount Poly, it was a centerline design, and it also included an upstream construction design. This dam failed because the design did not consider soft spots in the geology where the dam was sited. Okay, they have problems with the foundation. And the original design, which includes specific downstream slopes to properly support the facility, they weren't met. And what happened? They found themselves with a lot of water in the tailings dam, and had a problem with liquefaction there, and that's why it failed. This failure from the Mount Poly facility underscores the importance of managing the water content of the tailings beach for both the upstream and the centerline construction methods. Again, this is not a problem for the downstream design that Donlin has proposed. And we should also note that the Donlin Gold Dam includes a foundation on bedrock. The Fundão mine in Brazil, they had their tailings dam failed in 2015, and they had an upstream construction method the failure was caused because they had waterlogged tailings that got too close to the tailings dam and liquefied and lost their strength and had a catastrophic failure. The Cadia mine in Australia, they had a tailings dam that failed in 2018, and this dam actually started as a downstream, and very early on the life of the project, it switched to an upstream construction. Okay, they had a problem also with liquefaction. They got water too close to the front of the tailings, and it failed. But the part that failed, it wasn't the downstream construction part. It was the upstream construction that failed. And then the Correio Feijão mine in Brazil, also an upstream construction dam, and similar problem. The water got towards the front of the tailings, where it's not supposed to be, and it caused a catastrophic failure on that dam, as well. So again, to the point that I started, the Donlin Gold tailings dam construction method is fundamentally different from the facilities on Mount Poly, Fundão mine, Cadia, Feijão, and would not be susceptible to the same types of failures. And with that, I'm gonna switch it to, I'm gonna let Chris Eckert. He's gonna talk about permitting and monitoring, for tailings dams.
Enrique, if I may, this is Christina. Just one thing that we do want to point out, while this area is not known to have significant or even really moderate seismic activity, the design encompasses that any level or sizable level of seismic. And so while it's not necessarily the situation locally, we do go above and beyond in the design to account for that. And so in addition to the liner, supersedes the, goes above and beyond for this particular environment. So we just wanted to be sure to note that.
Thanks, Christina. All right, Chris.
Yeah, so in the earlier presentations, there were some questions about, the dam permitting and the design and information that wasn't quite available yet. And that's what we wanted to cover here. So in Alaska, when we go through the permitting of a dam, it's a multi-step process. Where we're currently at is we have our preliminary design completed, reviewed, And we're gathering additional geotechnical information to create what's called the detailed design package. And after that is reviewed, then we would develop the final construction package, and that has all of the detailed engineering drawings and designs on how to build the dam, the material specifications for the dam, and basically how you're going to build the dam. And after that has been approved by Alaska Dam Safety, they'll issue us our permit to construct the dam. Then, as we're building the dam, if we have any modifications to the design, we have to go back to Alaska Dam Safety and get approval for those modifications there. And after the dam is all constructed, then we develop our construction completion report, our QA/QC report, which is making sure the line that's check to make sure that the dam was actually built as designed. Our operation maintenance manual and the emergency action plan, all of those are submitted to Dam Safety for approval. And after Alaska Dam Safety is satisfied with everything, they'll issue us the certificate of approval to operate the dam, which then will finally allow you to start filling the dam with water on there. Prior to that, you cannot, the dam will not be in operation. And since we're building this dam, the tailings dam in 7 stages, each of the 7 stages goes through the same process. And with an additional step of, as each additional stage, we look back at the performance of the design in the initial stages to make sure everything is performing as the engineers thought it would. So as part of the detailed design package and once we start construction of the dam, we start developing what's called the emergency action plan. And for both the Snow Gulch Dam and the main tailings dam there, those are both going to class 1 dams, which will require this very extensive emergency action plan on here. Part of that, what we do is we look at how much water, how much tailings are going to be in the dam at each stage as we're going along. And then there's an analysis done where they look and say, how could the dam fail? What's the failure modes? We rank all of those. And out of that, you come up with a model that's an inundation model that says, okay, if the dam fails, where's the water go? How far down does it go? What structures may it impact? And then we take all of that and working with the community, we develop the communication plan on how we would notify anybody downstream of a potential issue with the dam, what we need to do, but also if you start seeing issues with the dam, what's the corrective action that you need to take to prevent the dam to fail? The whole purpose, the majority of the emergency action plan is everything steps you would take that before you get to a point where you actually have to notify people downstream and say there's a problem, we need to move everybody out. It's a very conservative plan put together to make sure that to prevent a failure from happening. And then annually that plan is reviewed. And then every 3 years, as part of that, we have to exercise the plan. What that means is we'll pick a failure mode and do a field drill on what we'd have to do if this happens, so that the people on site, the crew on site know what to do, but also the people downstream that would be responding to this would be included in that drill, so that everybody knows what's going on and what happens, so that if we did have to activate the emergency action plan, it's not a surprise to anybody. The emergency responders know what's going on, what to do. The people are informed, and it's not a panic situation. Now, within the dam, there'll be a large amount of instruments that will be put into the dam to monitor the performance of the dam. They'll include like the thermistors, which will monitor the ground temperature, to make sure if the discontinuous permafrost is melting as designed or as predicted. Now, piezometers would be installed sort of upstream in the tailings and in the dam, as well as downstream of the dam. And what a piezometer is doing is it's just measuring the water level. So what you want to know is within the dam, there's a flow of water that goes down to the seepage pond. And we want to make sure that needs to be at a very predictable rate there to prevent any internal erosion in the dam. So that's monitored very closely. Inclinometers, and what those are is that they're an instrument that's put in that will tell if the dam is tilting at all off of there. It's like a big long wire that's put in there, and it just measures tilting down to half an inch, a quarter of an inch there. And then also survey monuments that would be measured just to see if like the crest is sinking or not. And then additionally, we probably install a seismograph out there, because what we're worried about with an earthquake is not the shaking on there. It's actually the ground movement and the energy in the ground that arrives at the dam there. So the engineers wouldn't want to rely on, seismographs that are hundreds of miles away at home. What's that there? They want to know right there what's going on, so you can know if we're within the design capacities of the dams. Also, we may install slope monitoring systems, and these are like a radar or laser system that is constantly surveying the slope of the dam to determine any movement in the dam there. Those are fairly interesting during snowstorms to watch the snow build up and then melt back down, that kind of thing. And then also, video systems are really nice out there, are good instruments on there to be able to model for or look for if somebody says there's something, if one of the people say that they find something wrong in the dam, they could look at it immediately and see and know where they need to go. The on-site engineers know where to go and look for it. And then all of these instruments would be part of the operation manual. They would be included in the operating and maintenance manual for this. And inside there, we would, in the O&M manual, we would establish action triggers where there would be several levels. One is where just the on-site engineers go out and look at things, and if it gets if the instruments get further out of whack, then we start escalating up to where we're talking to the engineer of record and potentially having to notify the public. Then the instruments aren't very good. If we're not out there inspecting the dam, having the instruments in there doesn't do much good. So within the operation and maintenance manual, there'll be various inspections that will be identified, as well as the frequency. There'll be, daily or weekly inspections where, like, an engineer and technician is out looking at the dams, just doing a visual check of the dams. Also, the workforce, if you're working in the area of the dam, you'd be instructed to, if you see anything strange or weird on the dam, to come and talk to the on-site engineering department engineer so they can go out and look at it. And then usually on a quarterly basis, an engineer would be out walking the entire structure of the dam, checking for settling cracks, signs of seepage, movement in the slope, those kind of things there. Then annually, the engineer of record, and this would be the engineer that actually designed the dam and came up with the dam. He'll come out annually and do an inspection where he'll look back at all of the inspections that have been done by the on-site engineers and do his own inspection, make sure to check for the design of the team, or the design, the dam's working as designed. And then every 3 years, there'll be another engineer that will come out that was not involved in the actual design of the dam. And he'll come out and he'll critique the engineer of records design, how the dam is performing, and look back at the design basis, make sure everything is looking right. And it's just give a fresh look at the dam every 3 years. Then and then when we look at all of these reports, all get generated, and they'll all be sent to Alaska Dam Safety for review and approval. And as well as if we find any significant findings in any of the inspections, those are sent to Alaska Dam Safety as well with what our corrective action plan will be for it. Then the landowners, they'll also be reviewing the various reports coming out off of the dam. And as we move into the detailed design phase, providing input in the reviewing process of the dam to make sure they're comfortable with the design as well. And then Barrick and Nova Gold, as the owners of the dam, they'll institute what's called an engineering review board. Now, what this board is this is another set of dam engineers that are very senior. These are the guys who've been designing dams and working in the field for years. And their sole job is to take the design that the engineer of record has come up with and critique it and come up with any possible flaws in the design that the engineer of record will then go and either defend his design or modify the design to so that it is as safe as possible design that we could have. This will be done throughout the life of the mine as we go through each stage of the dam or dam construction.
Okay. Well, thank you, Chris. That was a good explanation of the permitting and monitoring for the tailings dam. And I think we're gonna go ahead and move on to the next topic, which is Crooked Creek water temperature and stream flow. The EIS took consider that the effects of potential changes to water temperature in Crooked Creek as a result of changes on stream flow from the project. We actually took a deeper dive into this concern, and we did an analytical and quantitative study to really try to understand this and the potential there. So let's start talking about what are some of the proposed what are the potential changes from the project. And we need to start talking about we need to start the conversation by talking about how the project is going to be managing the water. Okay, so I'm going to go very it's a topic that we could spend probably days talking about, but I'm just gonna try to summarize it in a nutshell. Okay, this map here it shows maybe give you the bearings. Here is Crooked Creek, okay, which flows into toward the Kuskokwim, and this is the mine area, and there's multiple small tributaries. Here is American Creek, and here is Anaconda Creek. Okay, in American Creek, we're going to, that's where the deposit is located. So that's where the open pit would be. And then these are here. This is where the waste rock would be, and this is where the tailings facility in Anaconda would be. So all the water in these watersheds, okay, it's going to be managed by the project. I mean, Anaconda for American Creek will be capturing, almost the entirety of that water, okay, and a big portion of the water in Anaconda Creek will also be captured. Okay, all that water that is captured is used for the project, and also whatever water is not needed is treated and discharged back to Crooked Creek. Now on the pit, we will have a number of dewatering wells. Okay, here's schematic, just a cartoon of an open pit, of the open pit. All right, so you can see the hole on the ground, just to make it simple, and we would have wells inside the pit and around the pit, okay, to intercept water so it doesn't get into the pit. Okay. Every time you have one of these wells, it creates what is referred as a cone of depression. Okay, it basically dries the land, around it. And as the pit grows, that cone of depression also grows. When we get to about year 20 of operations, we expect that because of this dewatering wells, we'll also be capturing a little bit of the water from Crooked Creek. Okay, so to summarize it, we have reductions, we're summarize and simplify it, okay? We're gonna take the water from American Creek, most of the water from Anaconda, and then also a little bit of the water from a little portion of Crooked Creek, okay? So that's gonna result on some flow reductions in Crooked Creek, okay? Now, we have less flow. There is a greater risk of the water temperature to increase, okay? So let's look at some of the data that we have for the project for temperature, because we collected water temperature for a number of years. We have continuous temperature, different locations on the creek. And I just want to show you these charts. They show the temperatures on the water for multiple years at different locations. Here's by American Creek, here's by Anaconda. This is farther down by Crevice Creek. And this chart shows the data between June and October. So basically, throughout the summer. You can see how variable that data is from year to year, from location to location. But the one thing that I want to point out to you, 2005, that was the warmest year record, the warmest year that we have on record, okay? And you can see that the temperature, it's, it gets, especially at Crevice, which is the farthest one, it gets, close to, it gets about 51.6 degrees, okay, which is close to the water quality threshold for egg and fry incubation and spawning, okay, which is 55.4 degrees. And then there is also a threshold for migration and rearing of fish, which is 59 degrees, okay? So we looked at this data, okay, and we looked at the warmest year on record, okay, and we modeled, with the warmest year on record. And that's what I show you here. If we were going to, if we look at the water temperature, sorry, I gotta take a sip of water. If we look at the water temperature, without considering the treated water discharge, again, using the warmest year on record, we'd be looking at a little increase in the temperature in the creek, okay? But we're still below the water quality standards. Okay. If we look at the temperatures and we consider the treated water, and the treated water, it can have a range in temperature, right? A lot of the water that for the project is gonna come from groundwater. And then it has a temperature of about 40 degrees. And then we have, we're pretty sure that, we will be discharging, at temperatures that are lower than 55. But just to be conservative, we model here both ways. What if we discharge at the maximum temperature that we could discharge, 55 degrees? And what if we pour water at the coolest temperature that we have, which is 4 degrees, right? So the yellow one is the highest temperature. So if we were going to discharge it, with the treated water at 55 degrees, we would see, an increase in temperature very similar to before, but still below the water quality standards. If we were going to discharge at a temperature of 40 degrees, we could actually see a cooling on the water over what we saw in 2015. 2005. Okay, so this is telling us something very interesting and very important. Oops. And it's that we actually, have the capacity to, if needed, to regulate the water in the creek. Okay, I mean, as it is, we are below the standard, but if needed to, we could mitigate, temperatures. So, just to summarize, we're not, the project is not going to result in water temperature increases above the water quality standards. So that's for water temperature in Crooked Creek. And now we're going to change the focus to mercury. Okay. And I'll start by saying this. Okay. That the project is not going to exceed the water quality standards for mercury. And I'm going to explain that to you. I'm going to explain to you. And this is because of the work that we did last year. Let's talk, first, let's talk a little bit about the mercury cycle. All right. Mercury, it's a naturally occurring element. It's on the ground, in the environment. It's in the atmosphere from releases of industry, smokestacks, also some natural event, volcano or sublimation from the ground. Once it's on the air, mercury is deposited on the watersheds, with the rain and snow, as gases, as particles. And once it falls to the ground, mercury, it migrates, it can migrate and be transported by water, and it makes it into the creeks. And in the creeks, some of this mercury is converted to methyl mercury. I should note that the water quality standard for mercury in the state of Alaska is 12 nanograms per liter, which is one of the lowest, or the lowest in the nation. And once it's methyl mercury, can be uptaken by wildlife, and which is a big concern for the region because of the consumption for fish. Now let's look at how the mercury was analyzed in the EIS. In the EIS, there was an estimate for the amount of mercury that would be emitted for the project, okay? And that amount was 89.3 kilograms of mercury per year. Mercury is a very heavy element. This was a conservative estimate. Now, based on this number, it was calculated that about 40% of that would result in a 40% increase in atmospheric mercury deposition. Now, if we assume, okay, and this is a big assumption, it was conservative, that all mercury that falls onto the watersheds, that is transported to the water, okay? Anything that gets deposited onto the land, all of it makes it to the water. And then also let's just assume that all mercury comes from the atmosphere, okay? Let's ignore that it comes to the ground. So with all these assumptions, it was estimated that the project would increase the mercury water quality by 40%. And even with that number, of that large increase of 40%, it was calculated that the average concentration for mercury would still be below the water quality standards. I mean, this was a very conservative analysis, okay? So last year, we sharpened our pencils on this subject because we understand that this is something that is of concern to the region. And I want to show you here a chart that shows the mercury concentrations for Crooked Creek. This is from all the data that we have measured over the years. And what this chart shows, it shows in this side here, it tells you the concentration of mercury. The higher up, the more mercury. And on the bottom, it tells you turbidity. The farther you go to the right, the more turbid that the sample was, okay? This yellow line is actually the water quality threshold of 12 nanograms for the state of Alaska. So these are all samples from Crooked Creek. This is all natural conditions. And you can see that there is a portion of the samples that exceeds naturally the 12 nanograms per liter. Now, what this graphic tells us is that the higher the mercury, typically also the higher the turbidity. And that makes sense because mercury is in the ground, it's in the geology of the region, okay? And what happens is that whenever you have a high flow event, like for example, a big rainstorm, or you have the breakup, right? That's when it stirs the sediments, it erodes the site, it erodes the creek, and it picks up more mercury from the ground and it carries from the water. Okay, so that's where the bulk of the mercury in Crooked Creek comes from the ground, not from the atmosphere. So with this understanding, okay, we went back to the model and we recalculated the mercury. So for starters, the number that was in the EIS for mercury, it was very conservative. A more realistic number based on all the mercury controls that we have for the project is 30 kilograms of mercury a year. Okay. Now, before the EIS made the assumption that all mercury was going to be, that falls in the ground was going to be transported to the water. That's not a realistic assumption, okay? Because a lot of the mercury that falls in the ground, the great majority stays on the ground. It does not travel to the creek. So we actually collected samples and compared it with other studies that have been done about this subject. And only about 7% of the mercury that falls on the ground is actually transported to the water. And also, we have to know that a lot of the mercury that falls on top of the mine facilities, all that water is going to be managed. So that's mercury that is not going to reach Crooked Creek. And we also need to factor the fact that American Creek and Anaconda already have mercury in that water. We're going to capture all that water and we're going to treat it, okay? So we're so just by doing that, we're also removing inputs of mercury into Crooked Creek. So when you factor all these things, you actually come out to a much smaller number than what was in the EIS, which is a negative 1.6%, okay? So to answer again the question that we started from the beginning, no, the project is not going to increase mercury in the water quality in Crooked Creek. That is not what the science is telling us. Just to oversimplify what I talked here, okay? Let's just look at the conditions now. Let's just imagine that mercury, it's apples, okay? So right now we get 5 apples from the soil, and we get 1 apple from the sky. This is the current conditions, okay? When the project gets in operation and we start, we have our stock emissions, we're gonna add another apple, okay? Bringing the total to 7, okay? But because of the water management, we take 2 apples away, so we end up with 5. So this is just kind of oversimplify the process here, but this is the story that is telling here. Okay. And which brings us to the last topic of discussion for the presentation today, which is let's talk about fish and effects on fish in Crooked Creek. Okay. This map, it shows us the distribution of salmon in Crooked Creek, and this is the result of many years of studies, of aquatic studies in Crooked Creek. The thicker the line, I mean, we have three main species of fish, of salmon in Crooked Creek. We got coho, we got chums, we got chinooks, we got some sockeyes, but I really can't count the number of sockeyes with one or two hands that we get on a normal year. But the thicker the line, the more adult salmon that we see during the surveys. And if you look at the legend here, you can see that we're talking about tens of salmon per mile. We're not talking here about, hundreds of salmon per mile. So, but the majority of the salmon is distributed in the lower reaches of Crooked Creek and the tributaries, the large tributaries that are on the lower reaches of Crooked Creek. And that makes sense in part because there is higher flow and the proximity to the Kuskokwim River. Now, as you go on Crooked Creek and you move up towards the mine, you can see that this portion here of the creek, it is not very productive for salmon. And it's not until you get above Crooked Creek and you get into Donlin Creek, okay, that's when you see, better habitat for salmon. This is mostly, cohos. Cohos they're explorers. They like to move up the stream. But this area through the mine is not a very productive habitat. Now, when we talked before about the stream flow changes, those changes in Crooked Creek are going to happen mainly in this area here. Okay, you can see this boundary here is the predicted cone of depression from the dewatering of the wells that would peak at about year 20. And the EIS looked at these effects, and they did calculations, and they estimated that through this area here, okay, the water depth would change by about 1.5 inches. That would result in a 5% reduction of the aquatic habitat in this area here, or about 0.4 acres. If we look at the depth where we have seen salmon reds in the past here, it ranges from 6.9 to 16.8 inches. And the change on water would be from 5.3 to 15.3 inches. So just to give you an idea, again, this is just around this area that we're talking about. And the flow to this area changes a lot and varies a lot from one year to another. I mean, we've seen flow through here in March, which is one of the lowest months for flow in this part, range from 30.9 cubic feet per second to about 9.9 cubic feet per second. That's about a 68% difference. So there's a lot of variability on how much water moves around here from year to year. But once you get below this area, if you get around here, between Omega and Anaconda to Crevice, you can see that the change in flow in water depth it's about 1 inch. And once you get past that point and you move farther, it just becomes unmeasurable. So how do these changes affect spawning for salmon? In 2009, we did a salmon, a red survey. And what's special about this year is that we actually GPS every single red that we found on the creek, okay? And just to make sure that we all understand, a red is it's a nest on the gravels where the salmon lay their eggs, okay? And we counted from the mouth of Crooked Creek all the way up to to past the mine. We counted 532 reds. Now, 94% of these reds were from here down, okay? So not from here up, but from here down. 88%, they were actually down here. So you can see that the best spawning and the bulk and the majority of the spawning area in Crooked Creek is way below the mine, outside of the area of effects for the project. Now, the EIS did some modeling, to try to understand the magnitude of the effects. And they looked and they said, okay, well, in this area here, the 2009 study, they found 28 reds. If we drop the water level 1.5 inches, we would lose 18 reds. Farther down, between crevice, so between here and here, there were 144 reds. If we dropped the water, we would lose 3 reds. And below that, it was pretty much unmeasurable, okay? So overall, if you look from this point down, there is 519 reds that we counted in 2009, and 21 would be affected. Now, that's just a measure to understand the potential magnitude of the effects. In reality, if you drop the water, the salmon is not going to spawn outside of the water, okay? But this gives us an idea and enough to understand that the effects to a spawning salmon are going to be minimal, and they're not going to have a population effect. Now, we don't stop here. We are going to be monitoring the aquatic life in Crooked Creek as we develop the project and before. In fact, we have already started. We have an aquatic resources monitoring plan that was developed in cooperation with the Alaska Department of Fish and Game. And it includes also aspects of compliance and requirements from multiple permits. It includes requirements in there for monitoring also from our wastewater discharge permit, the APDS, and includes also monitoring requirements from our fish habitat permits and also from our wetlands permit. And the aquatic resources monitoring plan is designed as an early detection system. What does that mean? It means that we're monitoring everything from the ground up along the trophic level. We're going to monitor the water quality. We're going to monitor the sediments. And then we're going to monitor the animals that live on that sediment, like the phytoplankton, the insects. And then we're going to monitor the fish, okay? So if something happens, before we detect a change in the higher levels, we're most likely going to see that change in the lower levels. So that's what I mean by, say, an early detection system. Things that we're going to be monitoring, we're going to be monitoring for fish presence and abundance. We have multiple stations, along Crooked Creek, get Muna, which is the most important tributary there, especially with when it comes to fish. And Bell, these are all the monitoring stations that we have. We'll be monitoring for fish presence, abundance. We'll be monitoring for aquatic invertebrates. We'll be monitoring for periphyton. This is the little zooplankton, little creatures that you can't see with your naked eye. We'll be collecting fish, fish tissue samples to analyze and see if there's any change in metals. We're going to be collecting surface water, water quality, and sediments. So we are going to do this on an annual basis. Also, we're going to be out there looking at the adult salmon that they return to the creek, and do annual counts, see the distribution, look at the number of reds, as well. We're going to be looking at flow. There is a number of stream flow locations that we're going to have on Crooked Creek. In fact, this year, we're going to be installing some. We're going to be looking and trying to understand this area a little better close to the pit, because right now it's questionable whether there's even water flow in some years going through here. And this is all information that gets captured annually on our report. We look at the results from the previous data, we compare to other years, and see if there's any change. And then this gets reported to the Department of Fish and Game. And that's the last of my slides. And I need a drink of water.
Perfect. Thank you so much for this presentation. We're now entering the question and answer period. And just to let everyone know, we are scheduled to go till at least 2:30. I apologize for not clarifying that earlier. If you have a question and you're using the Zoom app, we ask that you please raise your hand. If you go to the bar at the bottom, you'll see reactions. You click on that, you can raise your hand, or you can type your question in the chat. If you're on your phone, I know that can be difficult, so I'll just be calling regularly and asking people on the phone have any questions. If you're on your phone, to unmute yourself, you want to press *6. So with that, yes, and I know we have a few questions in the chat. And so we can get that were posted throughout the presentation, and so we can work through those too. And so just as we're starting, does anyone on the phone have a question? Okay, I'll call back on the phone in a bit just to make sure. I see that Grant, you have a question. Go ahead.
Can you hear me?
Loud and clear.
Yeah, I'm Grant Fairbanks. I'm spend my time between Bethel and Sleet Butte, and I've been studying this mine since its inception, and I've known the area before Donlin even got involved with it with the original miners. And my question is kind of a long one, so I'll just read it, and at the end you can try to answer it. The EPA cited this Donlin mine plan as having potential serious impacts on health, human health and environment, and increased concentrations of mercury and arsenic in the surface water and sediments. Fugitive mercury emissions from waste rock and tailing beaches are one problem, but stack emissions could be substantial. It is unknown how much ore will go through the thermal autoclave process and what % of mercury can and will be captured at the autoclaves and the carbon leach filters. Workers in the mine and the plant will be exposed to mercury vapors. Will mercury be measured all around the mine area and reported to the public on a regular basis? Or we, the public, will we need to fight to know these facts? The EPA isn't funded well enough to monitor the mine and the process facility on a regular basis. The EPA won't monitor stack emissions on a daily basis. How can we know what's happening, and how can we trust what we're being told? Some of Barrick's other mines have shown mercury problems in the surrounding parking lots and the areas around their mines. How will Donlin be different? We're advocating for a third-party monitoring system by local residents trained and results available to the public on a daily basis. What state-of-the-art mercury abatement controls will be installed, and have they yet been tested? Dry stacking was proposed as an alternative in the EIS, but Donlin told the Corps of Engineers that it would be too expensive. Recent industry developments show that it is possible with the use of 4 filter presses to process their 59,000 tons per day. Dry stacking is being done by new gold mines. Many countries and some states now require dry stacking. Dry stacking demonstrates a commitment to using best available environmental technologies. It reduces the environmental footprint. It improves tailing facility safety and stability. It reduces the need to extract water from local sources, allows for continuous reclamation, making final reclamation faster and easier. Dry stacking is a more sustainable method for storing tailings. Dry stacking could even eliminate perpetual water treatment for hundreds of years. Shouldn't Donlin redesign the mine plan in favor of a safer mine? The Donlin mine, as planned, will double Alaska's mercury emissions. Let me repeat that. The Donlin mine, as planned, will double all of the Alaska mercury yearly emissions. Mercury and perpetual water treatment is not acceptable. Can and will you show the public a better mine using dry stacking and better mercury containment and public monitoring? Thank you.
Oh, Mr. Fairbanks, that's a long laundry list. So I'm going to try to answer your questions, best I can, because there's a lot that you've mentioned here, and I don't know if I capture everything. But I'm just going to start by saying that I don't know the statements that you're saying about doubling the mercury, but just please refer to my presentation before that the EIS was looking at 80 kilograms per year of mercury emissions, and now we're looking at about 30 kilograms per year. So it's a much reduction, and that's because of our engineering controls that we have for the project. With regards to mercury emissions, the way air permitting works, you develop a model and you provide an estimate of the emissions that you're going to generate by the mine based on the engineering controls that you have, which are proven, okay? And based on those controls, you calculate your emissions. Compliance, the way it works with air permit, is actually one of the key, most involved tasks, for the project. I mean, there is a lot of requirements, for maintenance. And if you, if you're going to have, a specific control, okay, let's say you have a back filter, to capture dust, and put some mercury in there. You are going to, to have to show, maintenance with those items, okay? For some components, you may actually have to do a stock testing, to prove, compliance, with that. And all this information, it gets captured and recorded in maintenance records, which a lot of this information, it gets compiled into a biannual report that gets submitted to the state of Alaska, and the state of Alaska then reviews that information and to see if you are in compliance with those emissions that you projected or not. Okay, they review all this information with detail, and they go through every few years. They audit. And there is requirements and obligation, for Donlin to self-report whenever there is a violation. Okay, if you exceed the limits for any reason on the controls that that are in your permit, you're obligated to self-report that information. So, there's a pretty tight control on how the emissions for the project. We're blessed with one of our parent companies. As you know, Donlin Gold is a joint partnership between Nova Gold and Barry Gold. And Barry Gold is one of the leading companies in the world with regards to mercury controls. Their Nevada mines, they have very sophisticated mercury controls, and that's a lot where we're going to be driving from our expertise. There is components. There is other things that we are going to be doing, like that we'll be looking through as we continue to design the project. Like, for example, there is chemicals that can be added to the tailings that can further reduce our release of mercury from evaporation from the tailings, right? We have our dust controls. I mean, all of the tailings and all of the mercury emissions, for the project, are going to come from dust, and we're just talking about, exposure of soil to the wind, right? So it's going to be very important to use and implement dust mitigation to try to keep that dust down, okay? And that's something that it's key on every mine that I've ever seen. So I think I've covered all the questions here.
Yeah, I don't know what else is in there.
Thank you for your feedback.
Did we cover all of those, Grant, or did we miss some?
Well, you didn't touch about dry stacking.
I can touch on it.
One last thing is, you're talking about the small amount of mercury that is only going to be released.
I never said small at any time.
Well, but when you dig up the stuff, the ground, you're almost going to get an equal amount of mercury as you do gold. You're going to take the gold away, but I would love to have a good inventory of where all the mercury is going, because.
Oh, absolutely.
Yeah.
And that's actually something that will be very well regulated. I mean, we will know every mercury that is donated by the project because it's governed, mercury used to be a chemical that was an element that was used in industry, and we had it in lamps, and it was in a lot of things that we use nowadays. Cars have mercury switches, but as technology evolves, the use for mercury has decreased. And years and years ago, well, not that many, but the U.S. government, they passed an act that it was the mercury export ban. So there is basically not a use for mercury, or barely not a use for mercury in the US, and you can actually export it for other countries that may have a use for it either. So what the government committed, it was to build a disposal facility where companies could dispose of their mercury. So all the mercury that will be generated by the project and captured from all the mercury control equipment is going to be captured in flasks. We have 3 liters and 120 kegs that were, to place the mercury inside. This is equipment. These are packaging that is specially designed for safe transport of mercury. We also may have some activated carbon that may contain some mercury too, through some of the filtration equipment. And all these material, it has to be treated as a hazardous material. Hazardous disposal is very well regulated by the U.S. government. You have to track it cradle to grave. Every single flash that you generate is gonna be tracked individually or as a group for transport from the point that it was generated to the point that it was disposed. And then the EPA, if you're looking for more controls there, the EPA always gives records. So all this stuff is very well accounted.
I can address, Barbara. This is Dan Graham, General Manager for Donlin. The dry stack question, Grant. You know, that's obviously that's something that we constantly look at. We, in fact, we've taken another look at it recently to see where technology is. The issue we have is in our environment with this size of mine, you know, working in those cold conditions, 59,000 tons per day. The practicality of dry stacking and handling that, because even when you quote unquote dry stack it, you're still, you know, 18–20% moisture, and you try to move that around and it'll freeze quickly when you're, you know, running sub-zero temperatures. So we will continue to monitor that. Both Barrick and Nova Gold watch the ICMM and participate in their standards. The ICMM is an international consortium of mining companies that understand clearly that tailings is a huge liability for projects, and we all are looking for ways to build safer, as you say, sustainable operations. So it is something that we'll continue to monitor, and even if we can get a portion of our stream set aside and reduce the size of the tailings facility, that's something that we'll be constantly watching for. But as of right now, the technology is not there for our size of operation for that. And on your human health, I know I was trying to keep up as well. I see Curtis Chamberlain also was looking for your list of questions, but you know, the human health effects there, I don't know where your comments from EPA, if that was from the draft EIS, but as you know, between the draft and final, that was a key focus of completing the EIS, was to extend the human health assessment on the residents of the region and whether it would have an impact on everything from in the water to the fish to the berries and the fur-bearing critters. And the determination from that detailed review was that any changes to mercury would not cause a human health issue there. And we can point you to that study in the EIS that was completed in there. And then the last thing on that, we talked about doubling the mercury. I just looked up while we were talking. So National Science Foundation, well-respected entity, they estimate that just forest fires alone in Alaska emit almost 2 tons of mercury a year. Whereas as Enrique was showing, you know, our emissions are in the neighborhood of 30 to 50 kilograms a year. So it isn't a doubling of emissions statewide. So hopefully that helps.
Thanks for
Yeah,
go ahead, Grant.
so Dan, I meant for doubling of the emissions were from industrial sources, not forest fires or anything like that. So if you look at the state average of emissions from the industry, Donlin would double that amount. But I'm glad you're looking at dry stacking, because I really think that would help solve the perpetual water treatment problem.
Thanks so much.
And that you know, we look at that as well. We absolutely would. And we will continue to throughout the operation. If there's other ways we can manage any of our waste streams to improve the quality of that pit lake to a point where it wouldn't need treatment and would meet water quality standards, that would be best for everybody. We can agree on that for sure. And we'll continue to look at that.
Thank you both for the questions and for the answers. Just in the interest of time, I'm just going to move us on a bit so we can, because we have a lot of questions accumulating in the chat. If people have follow-up questions, if you have questions, remember you can raise your hands using the reactions and also post your question in the chat. So at the start of the presentation, Gloria Simeon had asked if there was any possibility, however remote, of any breaches to the Yukon. And Dan Graham, I believe you had commented in the chat saying no. Does anybody want to expand on this question? I can post it back in the chat. I know there's, we've been kind of going through stuff.
I guess the one clarification I would have on that, Barbara, was Gloria actually, did she mean to refer to the Kuskokwim, or was it the Yukon? I guess I'd ask Gloria that.
Gloria, are you able to clarify in the chat, or you can unmute yourself too? Are you still
Yes,
here? Oh, there.
it was the Yukon that I was asking about. I know that any breaches that would occur would certainly impact the Kuskokwim. I'm curious about the Yukon. Thank you.
Okay, thanks, Gloria.
The project is located in the Kuskokwim watershed. We have the only facilities that we have in the Yukon watershed. It's a very small portion of the airstrip apron. That's the only. So no, I mean that would be physically impossible.
Thank you. And then there were some follow-up questions from Gloria. Pending extreme weather, how will safe water levels be maintained? And how much water will be taken from Crooked Creek for the dam? And how will birds and game be deterred from mine activities? And I'll post them in the chat because I know there's multiple questions.
Okay. So, sorry, can you repeat the first question?
Yeah. Pending extreme weather, how will safe water levels be maintained?
Okay. So the dam, it has to account, the dam design, it has to account for extreme flood events. And what, 100 years, 200 years, Chris?
Yeah, so there'll be the maximum design flood number that will be generated. I believe that's what turned in. What they look at is really high precipitation year, everything flowing into the dam there, as well as storm kicking up, creating waves on the tailings pond and that. And that number is what's calculates in, and that becomes what's called the freeboard for the dam. And so you have, say, the top of the dam is at, say, like 50 feet. Say you have 10 feet of freeboard, so now you could only have your water at 40 feet. You have to maintain that 10 feet just in case there is an extreme weather event that causes a bunch of water to come into the tailings dam and the water level to increase quickly. And then that would be then treated and discharged out the creek.
Now, I think the second question was how much water will be taken from Crooked Creek? I mean, we're not planning on taking any water from Crooked Creek. Now, indirectly, through the dewatering of the open pit. We talked before about the conal depression. Okay. When we get to about year 20 of operations, we may be taking some water from Crooked Creek indirectly, but and that's just that water gets taken, with other water management in the project, and then it can get used, for the mining, and some of it may end up, on the tailings as part of the water management and water use for the project. But directly, we're not looking at, taking any water from Crooked Creek. All the water that we take from the project is from what is in the watersheds and used, for the water management. And then how wild birds will be deterred, from the mine activities. I think the first thing to understand is that this is going to be an industrial area, okay? And there's going to be a lot of activity going on: trucks, vehicles, people, heavy equipment. On the pit, we're going to have explosions. So it's something that just by itself, that type of activity is going to deter, wildlife from that area. The tailings, for example, I mean, it's not going to have any kind of, there's not going to be food or any kind of vegetation or anything like that to attract wildlife. So there's not really, attractions, for wildlife. With specific for the tailings, it's something that will be monitored. As far as the monitoring for the tailings, we have to look around to see if there's any signs of wildlife, to see if we see any wildlife. And these are things that you take in kind of based on adaptive management. We may get permits, for hazing wildlife, but if it becomes something that, hey, I'm seeing this wildlife, coming here every day, right? So you may take something to escalate that, if it would really become a problem, depending where it is, you may be able to put a fence to prevent that wildlife from accessing the site, or use a different type of hazing. But that's how we've done.
Yeah, there's active monitoring for wildlife on either in the pit or in the tailings pond that would have to be hazed out of the area. And those are also reported to the state as part of our waste management plan and reports.
I think what I hear sometimes very people concerned about the tailings specifically, because there's going to be, even though it's mostly going to be a lot of sediment in there, and there's going to be a little bit of water, it's a little pond maybe there, and people are concerned about wildlife, landing on the water and things like that. And quite often people has talked about, the birds are going to land and they're going to die, right? Well, I think that's kind of a relic, from the way things were done in times past too, for many projects, particularly for gold, where cyanide, was used in the process to recover the gold, and then the tailings that were discharged into the tailings pit include a lot of cyanide with that. Well, on our project, that is not going to happen, because that practice is no longer the standard and best management practices. We have, in our mill, it includes a cyanide detoxification process. Okay, so if there would be a bird that decides to land on that water and take off, because there's not going to be anything for there to eat, right? It's not going to stay there long. Not going to happen anything. Right?
Yeah, that's something where
if
it's
we
long-term effects is where a bird could get harmed.
Yeah.
And so as long as we push them off the tailings pond, if they try to get on there would be no real harm to the birds or to the moose or anything else in the area.
And for the record, I'm an avid bird watcher, so I love birds. So I don't want anything bad happen to them.
Perfect, thank you. Before I continue with the questions in the chat, does anyone want to ask a question? Anyone on the phone, remember you can also unmute yourself with *6. Okay, seeing none, I'm going to continue in the chat. So the next question, I'm going to combine a question from Mary Matthias and Gloria Simeon, because they refer to each other. So the original question was from Mary. Since Ms. Woolston said that Donlin has gone beyond requirements, why did Stanford not want a worst-case scenario for tailings dam failure addressed in the EIS? And the follow-up was, somewhere I remember being told that they were not prepared for that. What about air standards? And I can post these, again, I'll post these in the chat again.
For the dam failure scenario, why look at the worst case, for something that is so unlikely to happen, right? When we look at the dam failure scenarios, all these scenarios were very unlikely, and we took the most likely of the unlikely. So that's how we came up to this scenario that was evaluated. And Chris, I don't know if you got anything else to add to the permitting.
Well, as part of the detailed permitting in here, there'll be a failure risk modes analysis, which that will be, everybody will sit down and say, how could the dam fail? And if it fails at this point with so much water, so much tailings, how far down is it going to go? And there'll be multiple ways that'll be looked at on how the dam could fail and where that water would be flowing off of there. Whereas the EIS took the likely of an unlikely scenario off of there. Whereas in the failure modes risk analysis, you're looking at multiple ways the dam could fail and ranking how likely, or, you know, if it could happen, how severe would it be if it would happen? And then as part of that, then you understand where the dam could fail and you come up with a mitigation measure so that the dam would not fail in that portion, or if it does, or something starts happening, you have a pre-planned scenario in place to limit the failure and keep everything in and keep the dam intact.
Perfect, thank you. And then the next question was from Liz Mering. When you modeled for stream temperatures, did you account for the warming temperatures we are seeing across Alaska from climate change? 2005 won't remain the warmest year.
Yeah, I mean, we took, I mean, when we did the analysis, you know, if you look at if you recall the chart that I have or that I showed, I mean, it was, you know, the 2005 was way off the scale. Okay, so it is conservative from that point of view. Okay, you know, the analysis was done with the warmest year on record that we have, that, you know, we might not have had since then. You know, and then it's, you know, through the analysis we learned that, you know, with the project has the if needed also the, you know, the potential there to you know, adjust the water temperature to the discharge. So I think that answers the question, hopefully.
Thank you. And then the next question in the chat, actually, before moving on, I just wanted to see if anyone had questions that they wanted to ask. Again, on the phone, you can unmute yourself, *6. Okay, seeing none, I'm going to continue reading up the questions from the chat. And if I missed one, please let me know. I apologize. The chat can be very active, so I apologize if I missed one. The next question is from Grant Fairbanks, and it was EIS states that reductions to water flowing into the creek during mining water reduction could raise the temperatures above those needed for egg fry incubation and spawning.
Okay, I mean, that's the topic that we covered on the presentation earlier today. So it was, you know, a good question there. So the project, it is not going to increase the water temperatures, you know, above the water quality standard for spawning fry incubation. Okay, you know, even using the warmest year on record, it's just not going to make it above that threshold. And then we have, just like I mentioned before, the project has a capacity through a discharge to also, you know, adjust that temperature if needed.
Thank you. Another question from the chat from Gisela Chapper was the early detection system. How would water temperatures exceed thresholds, fish numbers are below threshold, water quality decreases, etc., impact the operation of the mine? And I'll post this one in the chat if it's.
I need to see that question.
Yeah.
Yeah. I just posted it in the chat again.
Let me see.
Are you
Actually,
able to see it?
I can give you a break and we can answer that one.
And you,
great question. So there's two parts to this, like some of the ones you're referring to about stream temperatures and fish numbers and stuff. So in that aquatic resource monitoring plan you referred to, we submit a report annually, and at the end of each year, we look at those results with the agencies, and you know, that would be one of those types of reports that we'd share through DATROC to subcommittees, to folks in the region to get feedback. But if we're seeing a trend there that runs counter to what the analysis showed going into the project for permitting, then there's a process referred to as adaptive management, where they look at our plans, see if we can determine a cause of what's causing an increase or an exceedance. And then the agencies can request that, you know, we work together to figure out what can we do to minimize that impact or reverse it or put it back to where pre-prediction levels or predicted levels. and then implement that change and review it again the next year. And that's part of that whole adaptive management cycle is you kind of keep an eye on this and see if you need to modify your operations. The other one on water quality standards is much more strict. When you have any sort of exceedance in a water quality standards, you have what you have to do is submit a corrective action plan. You have about 30 days to do your breakdown, do your assessment, what caused the exceedance, why is this water quality where it is, and what are you going to do to fix it? That one's much more stringent, much more strict, and much more prescriptive in how you respond to that. So there's a couple different ways on how these detection systems trigger changes, but they absolutely can lead to modifications in how you operate your mines. And I think maybe Chris can give an example. I don't know if Red Dog, they've been running for 20 some years. Have you guys seen changes in operations up there based on monitoring and any type of follow-up reports like that?
Well, the design of the water treatment plant was modified there. One of the elements that was cadmium is that the HDS system wasn't removing enough cadmium to where we went in and added in a sodium sulfate loop there to drop the cadmium out. It's what you have is your treatment plant is the best that we can model off of there. And as you start preparing to discharge internally, you're taking samples of the water before it goes into the creek, analyzing those on site to make sure that you're within your permit limits off of that, so that the idea is that internally you catch it before it enters the creek there if you need to make small modifications to the treatment plant. And that with Donlin's proposed water treatment plant there, it's pretty state-of-the-art design on there between the reverse osmosis and the filtration system and the blending of the water in there. But all of that, as we build up the plant, we would be testing the water, and at that point you would have plenty of storage capacity within the tailings pond with the starter dam that you would be able to be running the water, testing, and if the design needs tweaked, you'd have plenty of time to be able to add in additional treatment steps or whatever to be able to meet it and maintain the water balance. But that's just from a quick look at the treatment treatment dam. I haven't done a detailed dive into it yet.
Thank you. And Buddy, I see you have a question. Go ahead.
Yeah, good afternoon. I'm Buddy Cooch, council member with the Native Village of Georgetown. First off, I'd like to say thanks for everybody that's participating. Thanks to Donlin for sharing some information. And I see some familiar names and faces. It's good that everybody's staying involved. Question I have is, you guys gave multiple examples of dam failures using one of the other two methods you described. Do you have any examples of existing mines using your proposed tailings dam method? And that's it for now. Thanks.
There are known examples from tailings dam failures using the tailings dam design that were proposed for the project that we know. I mean, you have to think that there is a lot of dams in the world, okay? And there are places like, for example, just say China, right? That you don't hear everything what's happening there, right? But from everything that our engineers are reviewing, which are looking very thoroughly, everywhere, because they monitor every single. I mean, it's kind of like a plane safety, right? Every time there's a plane that unfortunately goes down, there's a board there investigating what's happening with dams. It's the same thing, and that's why this dam is designed well. But there's nothing that that we have found anywhere else in the world where there is a dam like ours that, that has failed, that has had a catastrophic failure.
Thank you. And Dan, I see your hand is up. Go ahead.
Yeah, I'll just add to that, buddy. Appreciate your participation here. We actually have a table, and I'll find it. We'll figure out a way to get it to you. But we did a breakdown. Maybe Vernon or Colleen are on and remember this, but we have I forget how many dams it is. There's probably a table of 100 or so dams around the world, and their type, and it has all the statistics that go with it, and it shows failures, and it gives you a good example of the various how the various dams have performed. And as Enrique said, it showed that the ones that employed the true downstream dam design throughout their life have shown to be extremely safe. But we'll get that information to you, and happy to follow up with you.
Yeah, I guess on that too, going stuff, it's not just the failure of the dams and the design. If there's incidents at the other dams across the world there, that's one thing where the engineer of record, as well as our engineering team on site, would take a look at that to make sure that we don't have the same type of issue with there. Is that it's not just, oh, failure of a dam, let's look at it. It's small incidents at dams get a lot of attention on site, where you look at your design and make sure you it's something that's not going to happen at your dam as well, or if you need to modify the design. So we just don't look at the big failures. It's little incidents, anything happening to dams, tailings dams. It's spread across the industry pretty quickly, and everybody takes a hard look at their design.
Thank you. Does anyone want to ask any other questions? There's also a few questions in the chat we can go through. And again, on the phone, *6 to mute and unmute yourself. Seeing none, we had a question in the chat from Gloria. Where will Donlin be conducting mitigation and reclamation for the environmental damage the development of the proposed mine will produce in areas of pristine wilderness?
So we have, right now through the section 10 and section 404 and section 10, basically that's our wetlands permit. There is a requirement for wetlands mitigation. There is, for example, in our mitigation plan, we have in there. Within the closest to the project, right there in the Crooked Creek watershed, there has been, placer mining for many years, going back to early part of the last century, and we've identified areas that the placer mining had modified. And we have included that as part of our mitigation. We're going to be taking those lands, and we're going to start restoring the wetlands and the aquatic habitat and improving it beyond what it is right now. And in fact, I have to say that we started that work last year. So that's something that is very exciting for us to improve aquatic habitat in the watershed. We have, we have some wetlands mitigation that we have outside. Also, in the Chuitna watershed, we're going to be doing a lot of land preservation there, and then we also have some wetland credits that mitigation banks in Brooklyn that we purchased. But with regards to also mitigation and habitat restoration. A lot of the projects, for example, the pipeline, right? The pipeline is going to be built as a dairy pipeline, but to construct it, we're going to have to add in there airstrips, camps. There's going to be some access roads that are temporary. As soon as the pipeline is being built, as the segments are being completed of the pipeline. All those areas are going to be restored and the habitat reclaim, right? I mean, at the end, all you're going to have is a 50-foot wide, cleared vegetation corridor. I mean, there'll be vegetation there, but tall shrub, needs to be cut off every few years. Just a 50-foot wide corridor. Everything else will be reclaimed, and and then for the mine side, again, you can't start a mine in Alaska or without first explaining how you're going to restore and close the mine, right? So for us, the tailings, it's going to be it will be capped, and it will be revegetated, and the same thing for the waste rock. So a lot of these facilities that we're going to be constructing in the Crude Creek watershed will be restored, or not restored, or reclaimed. Does that, hope that answers the question.
Barbara, if I may, sorry, I just realized you guys can't see me. I'm stuck in the corner over here. But Enrique mentioned the reclamation fund that's required before we turn a shovel to pay for the entire reclamation. But throughout the process, all along the way and going forward, Chalista and TKC as landowners will be incredibly involved with and leading the reclamation process. And so this is, paramount to all of us to, have a very good plan, and then the landowners will be leading that effort to that degree.
Thank you. And I see that Gloria thanked you also in the chat. The next question that was in the chat is from Curtis Chamberlain, and it's for Grant. He was asking if it would be possible for you to share the resources you referenced in your questions. Another question in the chat was from Gloria Simeon, asking what are the plans for monitoring in perpetuity?
Dan, do you want to take that one?
I can find my mute button. Yes, I can. So Gloria, yes, right now the approved plan does include both water quality treatment as well as monitoring in perpetuity. And what we are proposing is that we put all that money in to a fund up front, kind of like almost like a permanent fund that would be built up over the life of the project. So once mining is completed and closure is completed, it will leave a corpus of money that can pay for the annual monitoring requirements going forward. And this is something that has been a work in progress. The state, this would be the first time they've really entertained doing this, but they are intrigued by the idea and actually are getting to the point where I think they like this pre-funding better than even a bond. Normally a company would just pay for a bond to assure that work, but we're working with TKC and Chalista on the details of this, and it's underway, but that's the current plan still, is to provide a cash account that will pay for that monitoring going forward once closure is completed.
Thank you. Before I continue with the questions in the chat, did anyone want to ask a question? Buddy, go ahead.
Thanks. We all understand that there isn't a whole lot of seismic activity at the proposed site itself, but there is a large seismic activity in and around the proposed pipeline start along the Cook Inlet there and along the pipeline route itself. How is Donlin going to monitor any potential damage to this buried pipeline in regards to breaks or leaks or anything like that?
Absolutely.
Let's say there's a major earthquake again. What is the plan to access to take care or assess any potential damage?
Sure, absolutely. I think we all felt the earthquake a few years ago here in Anchorage, and it's something that we are very aware. But it's a good question. I mean, when we started the pipeline engineering and looking for routes, that's one of the first things that that we looked at, right? What are the geohazards, and earthquakes? It's an important geohazard that you have to include in the design. So there's two places. I mean, there's two places on the pipeline route. Remember, this pipeline is 315 miles long, and we've designed these as permitted these as a buried pipeline. It crosses two faults. It crosses the Castle Mountain Fault, and it also crosses the Denali Fault. Okay, so fault crossing with pipeline is something that is very well understood, and there's good designs on how do you do that. On those locations, the pipeline actually is placed, right on top of the fault. It's placed on the surface, and is built in a way that it can move. Okay, if there is a big seismic event, the pipeline move. And if you think about it, there has been several large earthquakes on the Denali Fault, and TAPS continues to put pump oil through that pipeline, right? So the first thing is design. Okay, so we already have a pipeline design that includes the understanding of the size of those faults. Now, there is other areas where we have geohazards in the pipeline that could be triggered by an earthquake. For example, there could be landslides, and we have a buried pipeline. So, if there is a landslide, you would take it with it, right? So those areas, we have identified those areas, and those are places where that we try to avoid already, through the pipeline design. And then we adjust for burying depth of the pipeline, and we also adjust for thickness of the pipeline. So all these things are factored in design. I'm not sure we'll be doing more as we in the future when we move advance the design of the pipeline, right? Now, in terms of emergency action, for the pipeline, just like a lot of components of the project, there's going to be emergency action plans or operation manuals, for what to do in case of emergencies. The pipeline is designed, for starters, with check valves every 20 miles, right? So if there is ever, there are leak detection systems, and if ever you detect, a leak, these valves would be, shut down, to minimize the gas release there. Okay, there is also a standard monitoring that you have to do. I mean, just there's annual requirements, annual flights that you have to do on the pipeline. Make sure you got to fly there right away. But for specific events, there is the check valves and pressure detection systems, leak protection systems that will be included in the pipeline design to detect any kind of gas leak.
Thank you. And Grant, I see that you have a question. Go ahead.
Yeah, Buddy brought up the idea of faults, and I've studied the USGS reports of this area from when they first started 80 years ago. And I saw what looked like an indicated splay fault from the Nixon fault coming within 5 or 10 miles of this mine. And in the original FEIS, I brought that up, and I've asked other people. I've asked a couple of geologist friends of mine, and one of them looked at it and said it kind of looked like it could possibly even be like the Denali Skip Fault. And I have not heard of any geology that Donlin has been doing recently. Sure. They have been more interested in looking at inferred resources as opposed to diving in deep on this. So I would like to hear from somebody in the future if anybody has studied this.
Yeah, I mean, I can tell you a little bit. I mean, we're keeping an eye on things, that's for sure. I mean, Donlin is, we're great supporters of the University of Alaska, and we actually have a monitoring station right now that the University of Alaska, has cited just next to the project. I mean, I would say within, just outside of our facilities area. There is a station that University of Alaska UAF has installed, and we are funding that project. So we are actually collecting data, and we are seeing reports. I think we've got a couple of them, with very minor seismic activity. So we are keeping an eye, on seismicity on the region. And again, it's just the design also on the tailings already. It includes, the design for a large earthquake. I mean, if you think about it, look at the design, when the Denali Fault, earthquake years ago, and there were no concerns with the folks in Fort Knox, right? There was no, the dam was designed, and we have a design that, actually it's more resilient to, to earthquakes than Fort Knox. So.
Yeah, my question was more, I know that there's a new station up there put in 2020 up by the mine, but that's just monitoring what happens now. But if you look at the old geological reports, there is an indicated fault, indicated meaning that they couldn't trace it any further. They didn't have time or money to go to it. But I was just hoping your geologist would go out and find the last indications and try to follow it to see if it does come right towards the mine, which is indicated.
I should check.
Actually, I can speak to that, Enrique. Grant, for the state dam safety certificates, we have to do what's called a preliminary design package, which is basically all the baseline information that feeds into a dam. And one of the requirements on that is what we call a near field fault study. And in fact, it's just that. And in fact, before we can even start on doing any of the designs, we have plans to send out at least 2 separate crews with a helicopter and do the entire mapping in the region. They actually land on some of these lineations that they see from air photos or whatnot, look at the condition of them, see if they can trace them further, see if they can see any signs of movement. So that is part of the baseline information that goes in. And based on that, they may adjust the seismicity factor that they want the project to design to as well. So that's work that's coming up in the detailed design for the structures. So hope that helps.
Thank you. And there's 2 more questions from the chat. Before we go through them, I was wondering if anyone had other questions. Okay, the next question I'm going to read is from Gisela Chapa. The assessment of the impact of the mine on salmon seems myopic and not account for existing pressures beyond our control, i.e. climate change. Given the current precarious state of Chinook salmon populations, how can you ensure impacts from the mine and associated development won't push Kuskokwim Chinook over the tipping point? And I can post this question in the chat too.
Well, I mean, we've been studying the watershed for many years. I mean, it's not something that that we just started, right? I mean, we've been monitoring from early 2000s, so we have a very good understanding of what's in the watershed and in the Crooked Creek watershed, and and there is any change throughout the years. When we hear about changes on the Kuskokwim region, we see those changes happening on the mine as well, right? I mean, for example, last year it was a pretty poor year for chums, right, on the region. We saw the same thing in the at Donlin, right? We still not done. We're still working on the report for last year, but we saw the same number. So some of the things that you see on the region, we're seeing that at a smaller scale in the watershed again. But I mean, you gotta look, at the effects of the mine. I mean, we are in the Crooked Creek watershed. Okay, Crooked Creek is not a main, tributary in the Costequin. And there's salmon on many tributaries, in the Costequin, right? So to say that something could happen at Donlin and could affect the entire population of salmon, the Costequin, it's a little bit far, and the changes that the potential for changes that we see on Crooked Creek are really minor, right? It's not things that you're going to observe. I mean, the salmon population on Crooked Creek is compared to the overall Coosacan River watershed is very small.
Thank you. And Buddy, I see you have your hand up. Go ahead.
Yeah, thanks. I got just a couple of questions. Gloria brought up some perpetuity stuff. Is there any estimated annual costs available that would maintain the health of the tailing pond after the mine is no longer in service? First question. Second question, in regards to potential barge traffic on the river and the cause for erosion at already sites that are already experiencing erosion. How does Donlin see the increased barge traffic having an impact on these areas of the river?
So barge traffic on the Costequin and erosion, I mean, that's something that it's been a concern. I mean, throughout the EIS, and we looked at it quite a bit. We actually went out and did measurements too of like when the barges go by and what kind of wave are generated. And you have to realize that these barges, they are shallow draft barges, so they don't generate the type of wave that you would see from other type of vessels, right? And what we learned too is that cost, you only need to look at the aerial imagery on the Costequin River to see how throughout time it's been changing left or right. I mean, it's never the river is constantly moving. And the main causes of erosion on the Costequin River, is the melting of permafrost and high flood events. That's when you get, the big erosion events that happen in the river. That said, I mean, it's something that we know is a concern, and we will be monitoring. We already have plans to do more work on that subject and continue to study more erosion in the Costequin.
Then was there a question on long-term water treatment cost?
Oh,
Yeah.
On that, if you go to the Alaska Large Mine, was that you, Dan?
Yeah, I can address that one. So under our permit reviews, Buddy, the state, we have to do an estimate of all those costs, and our current estimated cost post-closure, once we get a water treatment plant running, is about $3.2 million a year. And so what they have us set aside is the estimated closure fund needs to be just over $100 million. And then there's a small amount spent for the first 30 or 40 years before any perpetual treatment. is needed. The costs of monitoring that period are fairly minimal. And then once the main cost is running that water treatment plant. So that's the estimate used for that. And a couple other things on the erosion. I think we're still, as Enrique said, we're fully aware that's a key concern, and we're still trying to find ways that we can both identify and monitor current erosion rates. I think we need some baseline areas somewhere, some kind of a few sections or some places to set up monitoring now to see what natural erosion rates are, and then be able to monitor that during operations to see if we have any, increased effect in that. We're still trying to figure out the best way to do that from a scientific approach. But that's been something we've been kicking around for a couple of years now, and something that I would like to see get established within the next 2 seasons to figure out a way to get a baseline on a couple areas of the river that we can set up and use as our realizing erosion moves around, but at least to see if we're going to have any measurable change in the rate of erosion. And then going back to the previous question on the fish populations, one thing I've been keenly interested in, and I see Tish is on here with a list on, if there's any, we do a lot of community investment. Rebecca mentioned some of that earlier. And I've always thought it'd be some projects we should look at is ways to do other fish population enhancement projects throughout the watershed. If there's anything else out there, I know there's several watershed forums and different groups and intertribal watershed entities. And, that's one of those partnerships I would like to see us and find out if there's a role for us to play in helping with that, because we understand how important the fish is to the region. Obviously, we can't control that. None of us can with the changes that are going on further out beyond the regions of the Kuskokwim. But I think, there may be ways that we can find places where it's being, that we can help enhance that population. I'll leave it at that. Hopefully that answers or gets you an idea.
Thank you. And I see, Grant, you have a question?
Yeah, in regards to Buddy's question about erosion, I've read the whole EIS. I've read the whole thing about the barge traffic. I myself put in about 2,000 miles in a boat between Bethel and McGrath every year. I pass lots of barges every year. These are the same shallow draft barges, but barges that are here now is 1 or 2 barges being pushed. Donlin's is going to be a much bigger deal. There is erosion in the EIS. It's stated, and I don't know who these people that did these studies, that there's very little erosion recorded. Well, I can tell you for a fact that when these barges go by a sandbank, a cut bank, that wave from that barge goes up 2 or 3 feet, and there is sand that falls into the river, and you see little trees falling down. So there is quite a bit of wake. And then also from that study, it was talking about the prop scour from these tugs that are going to bring all these boats. And one of the concerns our group has is that the smelt spawning areas, all the smelt spawn between upper and lower Cowscag in about a 3 or 4 week period. And the studies show that these boats are going to be going through those spawning areas during that time. And we believe that that prop scour will hurt these smelt areas. And we're working on a proposal to have Donlin not be going through those spawning areas during smelt spawning time. So that's something that Donlin needs to think about, and they need to get some real-time people out there and not monitoring stations after the fact. They need to get out there and have some people with some yardsticks and some surveyors and take their particular boats that they're going to be using and go up and down the river and see what's going to happen, because nobody's ever done a study with their type of boats and as many barges as they're proposing.
Yeah, so Mr. Grant, I mean, this is something that that we're actually, we've been doing a lot of work. Then when the EIS started, there was, at that point, there was limited understanding on the rainbow smell. Okay, other than beyond the subsistence point of the timing of when people go out and catch them, and we've been catching up quite fast with rainbow smelt. It's something that on an annual basis we're paying attention. I mean, just during the EIS, we went out and first, we use some traditional knowledge information from residents in the area to really understand, where are they spawning? What's the reach of the river, right? So we did some studies and learned exactly that. Where's the area where the rainbow smelt are spawning? We learned the timing for their migration. We have a really good understanding now on where the timing is happening. Then we looked at the habitat too, and we studied, where in the river are the fish spawning? Are they spawning in the, everywhere in the river? Are they spawning in the shallows? Are they spawning in the deep areas, on the fast water or slow water, right? So we went out and, for various years and collected data to try to understand, also that exact same question. And we learned that the rainbow smelt are spawning. They're not spawning on the actual, main channel. They're spawning more on the kind of the moderate speeds, for the river, kind of the sides, of the channel generally. Okay. And we've continued to increase our knowledge. We started looking at, some basic questions, right? What's the age, of the fish, right? I mean, how old are these rainbow smelt that are coming up, up the river? Can that help us, understand if there was ever a population shift, on the, from the effects, of the project. So we went out and, we have, a couple of years now of age information and starting to get an understanding of the population and age distribution for the fish. Last year, we did a very interesting study, which we're still analyzing the data, but we look at the timing of the rainbow smelt. How long does it take for the eggs to hatch? And how long does it take for the larvae? Because we're talking about very tiny, several millimeter long, larvae that comes out of those eggs, right? And how do they migrate out the river? So we actually had a very, very successful work that is telling us how fast these larvae are leaving the fish and where they are on the river. Now we know that all these larvae, when they migrate, and this is preliminary information because we're still analyzing the data, but they are everywhere on the river, and every time that there is a vessel, a small boat with a propeller, you're going right through it. All right, because we've seen it and we measure it now. So we are collecting a lot of information, and this year we'll be, we're in the process right now of designing studies, as well. So if you have any suggestions, feel free to, to let us know, if you have any thoughts about it. But we continue to collect, information about the rainbow smelt, and we're gonna start, moving into, collecting more information about the, potential, project effect. We already did some of that during the EIS, but we're gonna continue to collect information on that.
Thank you. And Curtis posted in response in the chat, I fully support the idea of fish enhancement within the region. I grew up commercial fishing since age 10, and the populations have been declining since the early 90s. I think this is something that the state or federal government should have started decades ago. I like that someone is looking at it and fully support Donlin's efforts in this area. There was one last question in the chat from Gloria. I know she's gone, but I'll follow up with her with your answer. And she had asked, I am curious about health effects that may be experienced by Native American tribal nations who live near the Elko mine. Were baseline studies done early on? Where can I find that information?
Dan, if you don't want to take that, I'm happy to.
No, I think that's something that we can get to her. We can reach out to the folks down there and get the background and get them the updates. Is that kind of what you were thinking, Christina? Because I don't have anything off the top of my head on that.
Sure. We know it's a priority and a commitment by the operators down there. I did want to say just in general, Barbara, that's been such a great conversation. And what we'd like to do is maybe some of the questions that had kind of a longer conversation and answer that maybe people didn't get to hear towards the end or throughout the conversation, if we could follow up with some Q&A response in writing, maybe some additional data, we'd certainly love to be able to share that with the folks that are participating today.
That sounds great. Thank you. There's no more questions lined up in the chat. Does anyone have questions they wanted to ask? Any final questions? While we're waiting, oh, sorry, go ahead.
I was just gonna, since there weren't any questions, I just wanted to say thank you for the opportunity to, for us to talk about the project. I mean, we've presented today information that is really fresh off the press. This is work that we did last year, and it was a great opportunity to be able to introduce it to to this public in this webinar. I mean, it's some of this information you're about the first to hear. So it was an exciting opportunity for us, and I really thank everybody for their questions.
Yeah, thank you so much. Thank you so much for staying on. We've been on for 2.5 hours, and I know that's a long time, but it was really informative, and we really appreciate everyone who asked questions, everyone who answered the questions, the presentation slides from Donlin. This was really great. And as mentioned, we're hoping to have another webinar with TKC that has not been scheduled yet. If you want to stay informed about when it is, please sign up for our list of georgetowntcenvr.com. I put the URL, the direct URL in the chat. We upload the recordings. I'll try and get the recording uploaded by tomorrow. The transcript is going to take a bit of time, and we'll talk so that we can also have those follow up to some of those Q&As. That would be great, and then I'll send it out to everyone who signed up for this. But thank you again, Donlin, everyone on the team. There's been a lot of work that went into this, and we really appreciate it. And to everyone who participated and asked questions.
Thank you.
Thank you so much.
Thank you. Have a good day.
Thank you. Hi, buddy.
Bye-bye.